hearing device to restore hearing to patients who have severe to profound hearing loss. The procedure begins by performing a mastoidectomy accomplished by removing the hollow bone behind the ear. After making an incision and retracting the ear forward to expose the mastoid bone surface, the honeycomb partitions of the mastoid bone are then drilled away down to where it connects into the middle ear. There are important structures that are preserved during this procedure, including semicircular canals responsible for inner ear balance, the bone that separates the brain from the mastoid cavity, the sigmoid sinus, which is a large blood vessel, chorda tympani nerve, which supplies sense of taste to the tongue, the facial nerve, which is responsible for facial movements. Once the round window is exposed, a well along with a channel are drilled into the skull upon which the implant is seated. The electrode array is then inserted into the round window and gently threaded into the cochlea. The skin incision is then closed. After the incision has healed, the external component of the cochlear implant can be worn to start the process of hearing restoration.
What the world sounds like through cochlear implants. One of our Patreon patrons, Captain Nick, recently wanted to know what the world sounds like through cochlear implants, which turns out to be a pretty popular and interesting question. Because if you don't have the implants yourself, you can't really know. Cochlear implants are one way for someone who's deaf or hard of hearing to hear speech, and to understand what they sound like, you might be tempted to put the business end of one up to a mic and listen. But if you did that, all you'd get is silence, because cochlear implants don't actually produce any noise. Confused? Let me explain. There are two main types of devices that help people hear: hearing aids and cochlear implants. Hearing aids are basically miniaturized amps and speakers, meaning the world sounds a lot like it would to someone whose hearing isn't impaired. Of course, for a hearing aid to work, the person has to have some amount of hearing in the first place. If they don't, a hearing aid won't help. Cochlear implants allow people with profound hearing loss or even complete deafness to hear speech by bypassing most of the ear altogether. What it puts out are electrical currents, not sound waves, which is why it's silent. Cochlear implants consist of a mic, a processor, and a receiver with an electrode array. The electrodes are surgically implanted into the cochlea, in case the name wasn't clear. Your cochlea is a part of your inner ear that converts sound waves into electrical signals, which then travel to your brain through the auditory nerve. It's a hollow tube that's coiled in on itself, which makes it look a bit like a snail shell. And it's lined with special cells called hair cells that trigger nerve signals when they detect sound waves. If these hair cells aren't working because they never have or because of some kind of damage, then it doesn't matter how loud a speaker you put in your ear. You won't hear sound well, if at all. So a cochlear implant kind of acts like a hair cell replacement. The electrode array is implanted so it can stimulate parts of the cochlea directly. The mic takes in sounds from the world and passes them onto the processor, which then crunches all that sound data and interprets it into about 24 channels, each corresponding to a different frequency of sound. For each channel, there's an electrode in the array that zaps a certain spot in the cochlea. So what you hear is what your brain interprets from the combination of signals. But those sounds aren't the same as what the mic picked up. There are thousands of hair cells in a fully functional cochlea, which is why hearing people can pick up a whole range of frequencies. With only 24 channels or less, the sounds from a cochlear implant are so different that a lot of people who get them essentially have to train their brains to hear. It's impossible to completely replicate what it sounds like without zapping your cochlea, but if you've ever heard one of those talking dolls when it's running low on batteries, It's a little bit like that. The channels the implant uses are specifically designed to amplify speech and make it interpretable, but they're not great at replicating the complexity of real-world sound. As one person with a cochlear implant explained to NPR, the implants especially fail at relaying pitch and timbre. Because of that, it can be especially difficult to understand tonal languages like Chinese, or to isolate individual voices talking in a crowd. Researchers are working on ways to make cochlear implants clearer, but for now, even the best implants we have make the world sound very different. But for those who choose to get them, it's a way to listen to and understand